Hello and welcome to my channel. In this video we are going to solve two questions from Circle Theorems which had appeared in Cambridge IGCSE 0580 Extended Paper 2 from May-June 2025. So let us start with the first question now. Now this question is referred from paper 2-1. A, B, C are 3 points on a circle with center O. DE is a tangent to the circle at point A. Angle ACO is equal to 35 degrees and angle BCO is equal to 40 degrees. Find. Now the first angle is angle AOC. So we have reconsidered the figure over here for easy reference. And since we are supposed to find out the angle AOC, let us consider the triangle AOC. Now in this triangle we can see that two sides of the triangle are same, that is the side OA and side OC, because these two sides are the radii of the same circle, so their lengths will be equal, and since the two sides are equal, the angles opposite to these two sides also will be equal. So angle C will be equal to angle A, so angle A will be also 35 degrees. Now once we have got two angles of this triangle, let us use angle sum property of a triangle to find out the angle AOC. So here we have written, consider the triangle AOC, and using the angle sum property of triangles, angle A plus angle C plus angle O is equal to 180. Now we have the values of angle A and angle C with us. So here we have written 35 plus angle O is equal to 180. Now 35 plus 35 gives us 70. So taking 70 on the other side of equal to sign, we get angle O or angle AOC as 180 minus 70. And 180 minus 70 gives us 110 degrees. So this is the value of angle AOC. Now let us move on to the B question. Find the value of angle ABC. So here we are supposed to find out angle ABC. And for this we have to use a circle theorem, that is angle at the center of the circle theorem. So let us consider the points A and C which are on the circle. Now according to this theorem, if we make an angle at the center of the circle, and using the same 2 points, if we make an angle at the circumference of the circle, this way, which is at point B in this case, then the angle at the center will be twice the angle at the circumference of the given circle. So for example, if at the circumference we had 40 degrees, then at the center we were going to have twice the angle at the circumference, that is 80 degrees. So now, since we have the value of the angle at the center as 110 degrees, the angle at the circumference is going to be half of the angle at the center. So here we have written angle at the circumference, that is angle ABC, is equal to 1 over 2 times the angle at the center, which is angle AOC. And we got this by using angle at the center theorem. Now since we have the value of angle at the center as 110, half of 110 is going to give us the value of angle ABC as 55 degrees. So this is our answer. Now let us move on to the C question. Find angle DAC, that is this angle. Now to find out this angle, we are going to use another circle theorem, which is radius tangent theorem. Now according to this theorem, the radius always makes a 90-degree angle with the tangent touching it. Now here we have the radius OA, which is touching the tangent DE at point A. So using the radius tangent theorem, we can mark the angle DAO as 90 degrees. And remember that we had got the value of angle CAO as 35 degrees because the triangle AOC was isosceles. So if we subtract this 35 from 90 degrees, it is going to give us the angle DAC. So here we have written angle DAO is equal to 90 degrees by using the radius tangent theorem. The angle DAO is made up of two angles, that is angle DAC plus angle CAO. So here, since we are trying to find out the value of angle DAC, let us take angle CAO on the other side of equal to sign. So we get angle DAC is equal to angle DAO minus angle CAO. Now the value of angle DAO is 90 minus angle CAO is 35. So 90 minus 35 is going to give us the value of angle DAC as 55 degrees. So this is going to be our answer. Now let us move on to the D question. Find angle OAB, that is this small angle over here. And we have marked the angle ABC as we had found it in the previous part of this question, and we need this angle to solve this question. Now to get the value of angle OAB, let us consider the triangle ABC. Now in this triangle, we have the values of angle C, that is the total angle is going to be 35 plus 40, giving us total 75 degrees, and value of angle B as 55 degrees. So using the angle sum property of the triangle, we are going to find out the value of angle A. So here we have written, using angle sum property of triangles, angle A plus angle B plus angle C is equal to 180. Now since we are trying to find out the value of angle A, we have taken angle B plus angle C on the other side of equal to sign, giving us angle A is equal to 180 minus angle B plus angle C. So here we get 180 minus angle B is 55 and angle C is 75. So 55 plus 75 is going to give us 130. So angle A is going to be 180 minus 130, which is equal to 50 degrees. Now once we have got the total angle A as 50 degrees, we know that the value of angle OAC is equal to 35 because triangle OAC or triangle AOC was isosceles triangle. So if we subtract 35 from 50, we are going to get the value of angle OAB. So here we have written angle OAB is equal to angle BAC, that is the total angle, minus the angle CAO. So 50 minus 35 is going to give us the value of angle OAB as 15 degrees. So this is our answer. Now let us move on to the second question. Now the second question is referred from paper 2-3. A, B, C, D are points on a circle. EF is a tangent to the circle at point A. AB is parallel to DC. Find angle DCB, giving a geometrical reason. So let us try to understand the question first. Now points A, B, C, D lie on the circumference of the circle as it is given to us, and EF is a tangent to the circle touching it at point A, and two lines are given parallel to us inside the circle, that is line AB and line DC. Now in the first part of the question, we are supposed to find the value of angle DCB, that is this angle, and we have to also mention a reason. So to find this angle, let us consider cyclic quadrilateral ABCD. Now we call this quadrilateral as a cyclic quadrilateral because all the vertices of this quadrilateral are on the circumference of the circle. And remember that we have a theorem for cyclic quadrilateral, that is opposite of a given cyclic quadrilateral add up to 180 degrees. So here angle A is opposite to angle C. So they both will add up together to give us 180 degrees. So here we have written angle DAB plus angle DCB is equal to 180 because opposite angles of a cyclic quadrilateral add up to 180 degrees. Now let us take DAB on the other side of equal to sign. So we get angle DCB is equal to 180 minus angle DAB. Now we have the value of angle DAB as 60. So 180 minus 60 gives us the value of angle DCB as 120 degrees. So this is going to be our answer. Find angle DBC. That is, we are supposed to find out this small angle DBC. And for that, we are going to consider the tangent EF and the chord AD. Now we are going to make use of a circle theorem, that is alternate segment theorem, which states that the angle that lies between the tangent and the chord is equal to the angle made by the same chord but in the alternate segment. Now this chord AD divides the entire circle into two segments. This is the small segment, that is the minor segment, and this is a larger segment, that is the major segment. Now this chord has made an angle of 35 degrees with the tangent in the minor segment, and the same chord makes an angle in the major segment at point B, this way. So according to the alternate segment theorem, the angle made by the chord with the tangent in the minor segment will be equal to the angle made by the same chord in the major segment. So angle ABD will be equal to 35 degrees. So let us write here angle ABD is equal to 35 degrees, that is by using alternate segment theorem. Now let us consider the parallel lines AB and DC. Now since lines AB and DC are given parallel to us and the line DB acts as a transversal line, cutting these two parallel lines at points B and D, angle ABD will be equal to angle BDC, that is the alternating angles of the two parallel lines. So here we have written angle ABD is equal to angle BDC is equal to 35 degrees. That is alternating angles of the parallel lines AB and CD. Now we have the angle D with us. Let us consider the triangle BDC. So now we can use the angle sum property of the triangle to find out the value of angle DBC. So here we have written angle B plus angle C plus angle D is equal to 180. Angle B is equal to 180 minus angle C plus angle D. Now we have angle C with us, that is 120, and angle D we got it as 35. So 180 minus 120 plus 35. 120 plus 35 gives us 155. So 180 minus 155 gives us the value of angle DBC as 25 degrees. So this is our answer. I hope you have understood all the steps and liked the video. And if you found this video useful, then you can check out this playlist where you'll find more examples of this kind. And if you're liking my videos, like, share and subscribe to my channel. And thank you for watching.